So for 4.4, we're looking at side, 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 and side angle side, and these two are ways to prove two triangles are congruent to. So let's jump straight to example number 2. On example number 2, Joey, let's read.
Write a congruent statement between triangles and state the postulate and lie. If you cannot apply a postulate, write no conclusion can be made.
So put a big fat star on this one. Now, we're not really doing a proof, we're just concluding something. So M is the midpoint of Ln. So if M is in the middle of Ln, what two must be congruent to? Good, LM and MN. And then here's what I want you to always notate. When I notate two things are congruent to, also write out, this is a side and that is also a side. And then it's also given that KL is congruent to KN. Let's also notate. KL is congruent to KN. What am I also going to write to the side of it? It is a side. Now, do I have a shared piece?
Yes.
What was that property called? Reflexive property of congruence. So do I have side, side, side in a triangle? Yes, I do. So here's our conclusion statement. Triangle, KLM, is congruent to. The order does matter, so watch the order of this one. I'm starting from the top to my left to the right. To be consistent, I need to go from what to what to what? K, N, M. Order does matter. And then our reasoning here is by side, side, side congruence. So let's actually apply that on a proof on the bottom. Now for this one, we have to write all the reasoning. Let's start with the first given. AB is congruent to BC. What is the reasoning for this one? Given. Guys, if I gave you a freebie on your quiz or test, please at least write the givens because I'm giving you points for it. If you go IDK, I can't give you anything, right? Write at least the given. That's like the minimum we can do. So we know AB is congruent to BC. Those two are side pieces, so I must write out S and S. Is there another given? Basically another freebie, right? D is a midpoint of AC. And that's also by the given. So if I know D is in the middle of AC, what can I state immediately after that? Good, AD is congruent to DC. And again, write out S as in it's representing side. So AD is congruent to DC. If you say CD, that's okay too. And that's by definition of the previous statement of midpoint. Definition of midpoint. Do I see a shared side again?
Yes.
Yes, I do. And notate that as S. So we have BD is congruent to BD. And what was the reasoning on this one? Reflexive property. Basically, if you look in the mirror, hopefully it is you. I know you're like, oh, sometimes it's not. All right. And then where do I write my final goal at all times? At the bottom. Is that a freebie too on a quiz or test? Yes. I'm still getting kids say IDK and I go, oh no. Come see me in tutoring. And then our reasoning here is side, side, side congruence. So only thing we added today on the proof was reflexive property of congruence that we're going to use quite a bit. So on the back, let's move on to example 6 and let's look at what side angle side looks like. All right. Yeah, number 6 is the same one that Joey read basically. Can we conclude something? So looking at this, let's look at our notations. What can I write between these two since I have it tick marked? It is a side. Do I see an angle that's also congruent to?
Yeah.
If it's got one swing and one swing, they're being corresponding, meaning they're congruent. So we have an angle, and we have an angle over here. Now, do I have another shared piece? Yes, I do. Here's my side. Now take out your highlighter. When it's not a side, 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 the order does matter. It has to be the closest tightly highlighted piece. Meaning, this side is stuck with the angle, and this angle is stuck with the side. So you read it as side, angle, side. It is not. Watch what I do. You can't start from side here and jump all the way over here, your side and angle. It is not side, side, angle. It is the closest consecutive highlighted piece. Are we clear on that? Okay? So for this one, put another star to this one. So let's conclude it like the first page. Triangle. If I go from triangle ABC is congruent to, how must I write the order to be consistent?
A, C, C.
If I go A, B, C, then I need C, D, A. Oh. Because A has that swing, and it goes over the side that is congruent to. So I need to start with the swing to the congruent side. Has to be consistent. Okay? The order does matter. And that will be by side, angle, side, congruence. So let's do a proof on example number 8 that has to do with stupid big mama cat. So hopefully you have the sheet in front of you. Okay, on number 8. How many givens did I give you?
Wow.
Now you want to say 1, but let's kind of read this in a separate manner. M is bisecting PN, and M is also bisecting KQ. So that's really 1 and 2 statements or givens. So let's write this out. M bisects PN. And that is by the what? Given. Should you miss this?
No.
No, it's a freebie. Now, maybe I can write out stupid big mama cat over here. Stupid big mama cat. I know my cats are not stupid, but it helps. So we have a segment bisector. The next statement I need to mention is what? Midpoint. So let's kind of analyze this. If M is bisecting PN, would you also agree M is the midpoint of PN as well? I need to mention that. So we know M is a midpoint. Have a good one. PN. And that's definition of segment bisector. So we got segment bisector, midpoint. What is C standing for?
Congruent.
So look at the picture now. What two segments are congruent to? PM and MN. And we need to also write out S for side. So we have PM is congruent to MN. And that's definition of midpoint. Here's what's nice about the fact that the first given statement gave us 3 statements. Am I going to repeat that for the second one on 4, 5, and 6?
Yes.
Yeah, let's do that. So we have M bisects. Who this time? KQ. And that's by the given freebie. So we know M is also what of the KQ then? Midpoint. And that's definition of segment bisector. And then what two must be congruent now? KM and MQ. And we should also write out what to the side? Sides. So we have KM is congruent to MQ. And what's the definition of? Midpoint. All right. We don't have a shared side here. But what do I have that is always congruent to? What kind of angles are always congruent to? Vertical angles. Do I have vertical angles here? Yes. So let's go ahead and notate. And let's write angle right in the middle. So for this one, you cannot name that angle as angle M. It's representing 4 different angles. So if I say angle PMK, oh, I said P and I wrote M. PMK. Angle PMK is congruent to something. How would I order the next one if I go from PM to K? If I go from P to M, which is 1 tick mark, I should go from N to M. N, M, Q. Now, if you reverse it, it's fine, because in the end, you're representing the same angle. I'm just being a little nitpicky. And this is because vertical angles are congruent too. And that we dealt with back in unit even 2, I believe. And then our last statement is pretty much given to us. Triangle PMK is now congruent to triangle NMQ. And let's go ahead and highlight this consecutively. Pick either of the triangle. I'm going to use the one on the right. As long as you highlight them together as tight as possible. Do we see the order of side angle side? Yes?
Yes.
Very good. All right. Is everyone good with that? So use stupid Big Mama Cat appropriately because it's going to give you 3 things, which is really nice. All right. I want to look at number 11. Okay, on number 11. Phoebe, let's read.
UTW is congruent to AXN, and angle U equals 4x plus 23, and angle A equals 6x minus 15 degrees, and angle T equals 2x minus 3 degrees. Find x and M angle.
So I gave you that these two are congruent too. So since we don't want to assume anything, let's draw 2 congruent scalene triangles. And I'm going to draw my triangle up here so I can do the work on the bottom. So I draw any 2 scalene triangles that look congruent to. And if it's not congruent looking, it's okay. Maybe the figure is not drawn to scale. So UTW does not matter where you start. So I'm going to say UTW. Do I need to be consistent in the order of the next one?
Yes.
Yes, I started the first one on top, so I must be consistent on the top, to the right, to the left. Let's fill in the information. Angle U is 4x plus 23. Angle A is 6x minus 15. And angle T is 2x minus 3. Is everyone good with that on so far? Okay? Since they are congruent to, which 2 are corresponding that I could set equal to each other? U and A, very good. Let's set them equal to each other. So we have 4x plus 23 is equal to 6x minus 15. Hopefully we can all do algebra 1. X equals some value. 19? Very good. So it says to find angle X, we did. And then it says to find angle M. So measurement of angle M. Now, angle M is corresponding to angle W. Is that correct? So can I plug in the 19 into U and T and add them together and subtract it from 180? Okay? So when I plug in 4 times 19 plus 23, and then plug in 2 times 19 minus 3. Someone give me the value of U and then T once you have them. Let's see. How many? 99. On angle U? Yeah. Do we agree on that? It is 99. Very good. Angle U is 99. Now plug in angle T. 35. Do we all agree on 35? T is 35. Oh, that's a 5. So now we can add those 2 together and subtract it from 180 to get W. How many is my W?
56.
Ooh, almost. 46. So since I know the corresponding part W is congruent to M, I can go ahead and write out 46 right here. And voila. And it's an angle.